Have you ever just sat there, staring through an industrial microscope for hours? Painstakingly tweaking those manual thresholds over and over, just hoping to get a passable grain size measurement? If you have, you know exactly how subjective, tedious, and honestly just exhausting that whole process can be. Well, welcome to this explainer. Today we're taking a really focused look at the future of metrology. Specifically, we're going to explore how Nikon's NIS Elements software is using artificial intelligence to completely eliminate that manual measurement bottleneck. We'll see how deep learning is literally transforming everything from basic grain sizing to complex weld inspections and even 3D surface analysis. So here's our game plan for today. We're going to cover the manual measurement bottleneck, AI-powered grain sizing, conquering difficult metal samples, guided weld inspections, cleanliness and 3D focus, and we'll wrap it all up with the automated lab.
All right, part one, the manual measurement bottleneck.
Let's kick things off with a daily frustration that pretty much every metallurgist and QC inspector out there knows all too well. The constant struggle for accuracy and repeatability in a busy lab is just a universal pain point, right? So ask yourself, are you currently doing grain size measurement manually with comparison charts? Or maybe relying on some older, basic image analysis software? Because if you are, you're probably fighting a constant uphill battle with operator variability. I mean, think about it. Two different technicians can look at the exact same sample, manually adjust those thresholding sliders in completely different ways, and boom, you end up with totally different grain size reports. It's a massive source of error, and frankly, a terrible drain on your lab's resources.
Okay, moving right along to part two, AI-powered grain sizing.
So let's take a look at a high-tech lifeline here, Nikon's flagship solution to this exact headache. There's a quote from our source text that I absolutely love. It says, "Segmenting grains using manual thresholding can be very tricky and tedious. This is now past." And honestly, they hit the nail right on the head. By using the NIS Elements AI Runtime module, this software taps into deep learning networks that have been trained on just massive amounts of sample data. And what does that mean for you? One click, fully automatic grain boundary detection. Seriously, absolutely zero manual thresholding required. You just click a button and the AI handles the entire heavy lifting. It's a real game changer.
Now, what's cool is the system doesn't just hand you some generic one-size-fits-all tool. Take a look at these three specialized pre-trained AI networks. First up, we've got the aluminium model. This one is specifically optimized for aluminium alloys and uses polarized light. Next is the austenite model, which is designed for austenitic and ferritic one-phase steel, relying on bright field observation after etching. And finally, there's the brass model, which is perfectly tuned for brass and similar copper alloys, again using polarized light. So these aren't just your run-of-the-mill algorithms. They are highly specialized neural networks built for exactly what you're looking at.
Which brings us to part three, conquering difficult metal samples.
The really crucial point here is how this AI tackles those previously impossible segmentation challenges. Because let's be real, in the real world, your samples are almost never perfect. If you've ever done this manually, you know the absolute nightmares that keep QA engineers up at night, right? You've got annealing twins that look exactly like grain boundaries, you've got uneven illumination or shading all across the sample, scratches from a less than perfect polish, or even interfering particles and inclusions. Traditional pixel-based thresholding just fails completely on these. It gets totally confused, drawing boundaries where there aren't any, or just missing the real ones entirely. But this AI network, it's been specifically trained to recognize and completely ignore those exact artifacts.
And honestly, this visual right here brilliantly illustrates that stark contrast. Just look at the raw bright field image of the austenite sample on the left. I mean, it's complex, it's got a bunch of internal structures, and those boundaries are definitely not uniformly dark. Now, look at the perfectly segmented colorful mask generated by the austenite AI on the right. With literally a single click, it mapped out every single grain with stunning accuracy. It completely ignored all that internal noise that would usually totally ruin a standard thresholding attempt.
Here's another incredibly tough sample. If you look closely, notice those parallel bands inside the grains? Those are annealing twins. And actually, if you look even closer, you can clearly see polishing scratches running right across the surface. Now, traditional software would look at those scratches and twins and just segment them as separate grains, which completely destroys your data. But the AI? It flawlessly identifies the true grain boundaries. It is completely unfazed by the surface damage and the twins. And that is exactly what separates this tech from everything else out there.
Of course, in a metrology lab, beautiful images don't really mean much if they aren't backed up by rigorous standards. Remember that single click we were just talking about? Well, it doesn't just draw colorful lines. It actually generates a complete, mathematically compliant report.
It calculates your grain area statistics, relative accuracy, and outputs your final ASTM grain size number in strict accordance with major international standards. We're talking ASTM E112, ISO 643, and even the Japanese and Chinese equivalents. The whole shebang.
All right, let's shift gears to part 4, guided weld inspections. Pivoting away from grain sizing for a second, let's explore how the broader NIS Elements ecosystem tackles another massive industry headache: weld cross-section inspection. If your lab is still out there measuring weld cross-sections manually with a Graticule eyepiece, well, you are leaving the door wide open for human error. Enter the Measurement Sequencer module. This tool gives you a foolproof step-by-step guided workflow. A visual schematic literally shows the operator exactly what to measure and in what specific order. The operator just clicks the corresponding points right on the live image, and the software automatically draws the overlays, calculates the dimensions, checks them against your preset tolerance limits, and then spits out an immediate pass or fail report. It is so smooth and completely foolproof.
Moving on to Part 5, Cleanliness and 3D Focus.
Now we're expanding the toolkit even further. You see, for automotive and aerospace manufacturers, technical cleanliness is absolutely non-negotiable. So the Filters module in NIS Elements pairs up with a custom Nikon scope and a motorized XY stage to automate your particle analysis. It actually scans the filter paper, then counts, sizes, and classifies every single particle. This ensures you're fully compliant with really stringent standards like ISO 16232 and ISO 4406. And the best part? No operator has to sit there manually counting tiny specks of dust for hours on end.
But what about rough surfaces? You know, like a fracture face, where parts of the sample are pretty much always out of focus because of the depth of the metal. Well, that's exactly where the EDF, or Extended Depth of Focus module, comes into play. Instead of leaving you with a blurry standard 2D image, the software captures images at multiple focal depths using a motorized Z drive, and then it stitches them all together. The end result? You get one perfectly sharp, fully focused image, plus a highly accurate 3D surface map that you can actually rotate and measure. It's incredibly cool to see in action. And finally, Part 6, the Automated Lab.
Let's look at how all these distinct modules, the grain size AI, the measurement sequencer, filters, and the EDF, how they all come together to build a long-term growth path for any metrology lab. What I absolutely love about this architecture is just how scalable it is. For example, you might start out at point 1 with the free NIS Elements LE software, maybe just to capture basic images from a new digital camera. But as your needs grow, you upgrade to point 2, adding the Detir software at the grain size module for standard compliance. Then, when you finally get tired of all that manual thresholding, you make the jump to point 3 by adding the AI runtime for that one-click automation. And eventually, at point 4, you're adding guided weld measurement, EDF for 3D focus, or maybe even using the NIS.ai module to custom train an AI specifically on your own unique proprietary materials. Basically, you get to build the exact automated lab you need, step by step.
As we wrap up, I want to leave you with a quick thought to ponder. When a deep learning network can flawlessly segment annealing twins and literally see through scratches faster and far more accurately than the human eye, how does that redefine the daily role of the QA engineer? Think about it. The QA engineer no longer has to act like a robot, painfully clicking through thresholds all day long. Instead, they're finally freed up to be true analysts, interpreting the data, spotting manufacturing trends, and actually improving the production process itself. The automated lab doesn't just change how you measure things, it fundamentally changes how you work. Thanks so much for joining me for this explainer, and I really hope this gave you a clear, exciting view into the AI-driven future of metrology.